Hello, my name is Aiden Leonard. I am a student at Joliet Central High School. This is a presentation about an assignment for my Orientation to Technology class, or OTT, as I'll be calling it in this presentation. Uh, the presentation is about the assignment called the Rubber Band Dragster. Takes place during the 2024 to 2025 school year. Um, so what is this project for? OTT is a class that Joliet Central has to offer that is to introduce students to all the tech electives and like work-based electives like woods, um, automotive, any architecture class and engineering classes, stuff like that. It's to introduce those classes to students, specifically freshmen. Um, This slide will be focused on the final assignment for the Woods unit of the class, called the Rubber Band Dragster, as I said earlier. Uh, this assignment took a total of about 2 to 2.5 weeks of class time. Each class is 55 minutes, and we are in school 5 weeks a day, and no, 5 days a week. And overall, in total time, I would say it would take a full day of work or spread out about 2, 3 days, for me at least. Um, the first step took place in a different unit. This was a engineering unit we did. We focused on designing the rubber band dragster, and we did this in Inventor from Autodesk. Uh, this was a software for CAD modeling, which is computer aided drafting. And we did a assignment, which was another summative final assessment for that, which was the rubber band dragster, but it wasn't making it, it was designing it in Inventor. We didn't do the full thing for time's sake. We just did the front and back wheels, which would be important for later because we would 3D print these wheels. And the steps were, first we learned how to use Inventor through a couple weeks of work, and then we would, once we got into the assignment, we would follow our teacher, Mr. West's assignment, um, which was a bunch of videos on how to make the wheel. So the first step was like sketch the outline of the rear wheel using the tools that Inventor has to offer. And after that, you would use a feature called extruding, which is turning a 2D sketch to a 3D object. We would do this with just a circle, basic circle, 2 inches big, and you extruded it uh, a half inch. And after that, you fill it, which is that little bend you see in the picture, the outside of the wheel, and then you do the same thing for the front wheel. After we had all of those parts, both wheels, we made what's called a drawing for you. They kind of resemble blueprints. Um, they are blueprints. The way we did this was also an Inventor. You took the um, models, the two models, put them into this drawing file, and after that, you just space it out, shade in stuff that needs to be shaded in, and this would be the set of directions we would follow through the whole thing. We only did the two wheels, as I said earlier. The rest of these pictures are also part of the full drawing made by Mr. West. But anyway, now to the actual woods unit. This is the actual assignment now for the woods unit. First step was the miter saw. Uh, this was basically just 3 steps. So first, we just went through basic safety and how to use the miter saw and when to use the miter saw. This is also known as a chop saw. If you do not know what a miter saw is, that might help. But first, we would take a um, piece of wood and mark it 2 by 6 and then we cut it using the miter saw and got the basic skeleton for the um, rubber band dragster, and then we would put our name on it so we didn't lose it, or if someone took ours, we knew where it was. The second step was to use the drill press to make the two axle holes. This was pretty straightforward. I have a picture of what it looked like after the drill press and what the drill press looked like. We went through the same basic safety stuff, and then um, when it came to actually do the assignment, we were given a piece of wood that one of our other teachers, who was a student teacher at Joliet Central, Mr. J, and he made a um, mold kinda that would sit the wood in, that would keep it straight so you could drill the hole through the piece of wood. Then we did prep for bandsaws, which we would consider also the safety for the bandsaw. And we did this on a SIP day, I believe. And we cut out the piece of paper that was scaled to the actual dragster from the drawing. And then we um, would trace it on the top of the wood, basically the side without your name, and mark what's called relief cuts. These are the cuts that you would cut first on the bandsaw so that you can cut through the wood with the curves. A curved piece of wood cannot be cut with the bandsaw because the bandsaw cannot turn. It is one straight continuing blade that goes in a circle downward, and it cannot bend. If it bends, it can break and severely injure you. And then you have some pictures. Next was the bandsaw. Um, we went and did what I kind of explained. You cut the relief lines, and then you cut around the shape. Do not go on your pencil marks. This is because you would have to sand later to smooth up the edges, and if you did that and cut on the line, you would lose the desired measurements and would go into your piece. And then I also had a little bit of jagged parts that stuck out, so I just trimmed them up to where I would have a nice surface to sand the dragster. Next step is sanding. I kind of went over this a little bit, very briefly, but we used a variety of sanders, and I have two of the sanders shown here. We used another one. I forgot what it was called at the moment. Uh, but this was to just smooth out everything and make it good to paint and just not be jagged and sharp so you wouldn't hurt yourself on it. And it also would technically improve aerodynamics in the dragster because of it getting rid of any uh, impurities in the wood. The next step after that was a hand drill, which we took the bit that was given to us by our teacher. Well, they did this, and they wrapped a piece of painter's tape around where we're supposed to stop because you couldn't use the full bit, otherwise you would go all the way through the dragster. Um, the way we did this was you just mark two holes for the dowel rods, which will be used to hold the rubber band on the dragster so that it actually works. And then you taped the drill bit, which was done for us. And then when you go to um, drill it, you had to make sure you had a mark and hold the top of the drill bit over the mark, and then drill at a 15-degree angle or closest as possible. Um, uh, then you just drill it. The hand drill used is shown above. Then we used and took and made the dowel rods and added the um, nail, the finishing nail to the back axle, which is one of the dowel rods. We did this by taking a big long piece of the dowel rod and marking the desired length for the cuts. Then we just took the bandsaw, cut them real quick so that we would have those done. But the rear wheel, we took and put it in the dragster in the rear wheel section, which is the back where the curve is. And this is the one that would have the big tires on it. And we took a finishing nail and marked up the middle, and then put the nail in the middle so that the rubber band would turn the axle, making the dragster move. Um, Painting, I took inspiration from the Nissan Skyline R34 GTR from Too Fast, Too Furious, and tried to replicate that as close as possible on the rubber band dragster. It was a little hard to do it with the two curved corners on it in the middle, but I think it went well. We used what's called the tape off method, which is where you paint any of your like lines or stuff in it. If you can see the blue lines on the skyline there, you would paint the whole thing blue, tape the parts you want to stay blue, then go over with your silver or gray. Um, then we did the actual testing. Um, this was just to make sure your dragster would meet the criteria of moving 5 feet or just 5 tiles in the OTT room. Uh, Also, this was when we were given our 3D printed wheels that we modeled in uh, Inventor earlier that I went through. This is the 3D printer that was used. Here are some videos. Let me load in real quick. All right. So this is with no rubber bands, which was an addition to it to make it be able to go quicker. Well, not quicker, to make sure to move in general. And the rubber bands, which allowed it to actually move the desired distance. So that's a good comparison of what it was like. Overall, my dragster worked really well. I'm very proud of it. I also found another way you could do it, which was by um, folding the rubber band twice, and it would make sure the rubber band wouldn't get stuck in the axle, which was a problem I had with it, which it would go all the way through, start moving, but then the nail would catch on the rubber band while it was sitting because it wouldn't go all the way back towards the flagpole, which is where it was supposed to go. So I fixed this by double wrapping the rubber band. This also worked, made the rubber band go faster and quicker, like just farther. And this project is probably my favorite project we've done in OTT so far. And it made me choose Woods 1 is one of my electives for the 2025 to 2026 school year. Um, my favorite thing about the project was using the bandsaw because I've never used or even seen one, and I knew about them. I just didn't know how cool they were in person, and I would like to do more projects with the bandsaw. Uh, I'd like to give a shout out to Mr. West for being a help during this project. Uh, I had an axle broke and he helped me fix it. Um, and overall, and just thank you for listening to this presentation.